Okay, so I just wanted to start by saying that like what I'm doing today is not exactly the most critical stuff. And so if you think about like, a cake, this is a horrible analogy, so I'm gonna just do it anyway. So here's the cake on the top of the table or of a plate, right? And so then you have the cake and then you have the frosting on the outside of it, and then you have all these little sprinkles, like the nice little colors on it that make it just kind of like pretty and whatever else, and like it just looks nice now, and it like doesn't like the sprinkles don't really change your ability to understand that this is a cake and everything, but like it just makes it look a little bit nicer and it makes it work a little bit nicer and everything like that. And so that is what we were doing today, was we were talking about the sprinkles of the cake. So far what we had done in this unit is the working on the cake and like critical stuff and all of the rules and all of the things that you absolutely have to know. This is the sprinkles. Okay, synthetic division is like another faster way to do division with polynomials than box method. And so what we're going to do is we're going to write the coefficients. I'm just going to do this first one first. I'm going to write the coefficients in order. The coefficients are the numbers next to the variables, which are 1, and then -11, and then 21, and then 16. Since we're dividing by -8, the root that corresponds to that, the solution that corresponds to that, the answer, the x-intercept on the graph is x equals 8. And so what we're going to do is we're going to put our 8 in a little like box over here to say we're dividing by this. See how this doesn't look at all like division at all? It doesn't look like the box method at all. I know this feels weird, but what you're going to do is you're going to start by adding straight down. So you get 1, because 1 plus 0 is 1. Then what you're going to do is you're going to multiply. You're going to multiply this 8 times this 1, and you're going to write the result right here. I know it feels weird. I'm going to show you that this works in a second. Then you're going to add, because you're going straight down. So you do -11 plus 8, and you get -3. Well, then you multiply -3, whoops, I want that in highlighted, -3 times 8, and you get -24. Well, then, since you're working straight down, you add, so you get -3 here. And then you get, then you have to multiply. So then you take this, and you multiply it with this, and you get 24. -24, sorry. Then you add, and you get -8. This last thing right here is the remainder. And then the other stuff that you have here is, okay, I'll rewrite this color-coded. 1x squared minus 3x minus 3. So what you can say is the answer to this division problem is this remainder -8. We'll do one more just to kind of get through it one more time. I don't have an x squared term there, and so I need to make sure that I have that in my problem. So I'm going to write the coefficients. It's 1, 15, 56, 0, -8, -54. And what I'm dividing by is the factor x plus 8, which means that the answer that I would get out is x equals -8. So that's what I'm going to put here. Okay, as I go down, I add. As I go across, I multiply. So I get -8 here. I add down, I get 7. I multiply over, and I get -56. Then I get 0, then I get 0, then I add, and I get 0, and then I multiply, and I get 0, and then I add, and I get -8, and then I multiply, and I get 64, and then I add and I get 10. The 10 is the remainder. And what I like to do is I actually like to count, I would like to work backwards. I like to work this way when I'm writing my answers. So my constant value, the one that doesn't have a variable, is -8. I'm going to have 0 x's. I'm going to have 0 x squareds. I'm going to have 7 x cubed, and I'm going to have an x to the 4th. So the answer to this division problem is x to the 4th plus 7x cubed minus 8, remainder 10. Some things to remember about synthetic division. What I need you to remember is that you always need to make sure that you have every power of x represented, from the greatest one all the way down to the least one. So again, I have a 0x squared here. It's not written, but it's there, so don't forget it. And then when you're solving these polynomials, remember that we usually use the box method and we just divide, and if it comes out even, then we can keep going. It's the same rule here. You have to make sure that your remainder is 0 when you're actually solving the equations that are polynomial equations that you're solving, because that's how you make sure that you actually have a factor. So that also might mean if you're solving an equation and you just kind of like didn't get 0 out at the end, that means that you probably don't have a factor. So I'm going to show you one that does have a factor, and that is a factor. This is a division that should have remainder 0. I wouldn't know that in advance, though. The answer that I get out from this divisor is that x equals -4. So put that here. Write the coefficients out: 1, 13, 36, 0, 9, 36. Okay, I know this is a little bit tricky. I know that I kind of ran out of space. I'm just going to kind of try to fix that with a little more space over here. So let's do that. Okay, so write down 1, then I multiply. -4 times 1 is -4, and then I add down. So I get +9. Then I multiply, I get -36. I add, I get 0. I multiply, I get 0. I add, I get 0. I multiply, I get 0. I add, I get 9. I multiply, I get -36. I add, I get 0. Hey, this is remainder 0. I like to draw little smiley faces in there. Okay, so when I get remainder 0, that means that I have a factor and I am able to continue on with my problem if I was solving the equation, but this one just came out even. So this is an example of remainder 0. And my answer is 9 plus 0x plus 0x squared plus 9x cubed plus x to the 4th. And so the result of this division is this. Okay, I'm going to show you how we would apply this to a problem. What we're going to do is we're going to find the zeros of this equation. That means that we're solving the equation right here. Okay, this is the graph of f of x, and so I have x equals -2 is a root, and x equals 1.5 is a root. Normally we would say, okay, so then x plus 2 is a factor, and we would say x minus 1.5 is a factor. But since I'm using synthetic division, I actually use the roots. So I'm going to use this value and I'm going to use this value when I put those in the corner of the synthetic division. So I'm going to do -2 here because that's what I have as the root. Again, if I was dividing by x plus 2, then I would switch that. So write the coefficients out. It's going to be 2, 1, 12, 9, -54. Add down, you get 2. Multiply, you get -4. Add down, you get -3. Multiply, you get 6. I'm going to stop doing the arrows now. Add down, you get 18. Multiply across, you get negative 36. Add down, you get negative 27. Multiply across, you get 54. Add down, you get 0. Your remainder is 0, and that makes you happy. Okay, so now what we have is f of x is equal to x plus 2 because of what we saw in the graph. And then what we have left is 2x cubed minus 3x squared plus 18x minus 27. Now we can take this, this, and divide it by the root x equals 1.5. So I'm going to put my 1.5 here. And I'm going to just use the coefficients here. So 2, negative 3, 18, negative 27. And what do I get? Okay. Add down 2. Multiply across 3. Add down 0. Multiply across 0. Add down 18. Multiply across 27. Add down 0. This makes me happy. Okay. So then, what do we get? We can rewrite f of x as x plus 2 times x minus 1.5. That's what we know from here and here. I guess the factors are written here too already. And then what do we have left? Well, we have 2x squared plus 0x plus 18 at the end. We're solving this equation equal to 0, so I can apply the zero product property at this point. Take a second, apply the zero product property, write your answers down, and then see me on the other side. Okay, so x plus 2 equals 0, x minus 1.5 equals 0, 2x squared plus 18 equals 0. All right. There's one. There's another. Minus 18, minus 18. I get 2x squared equals negative 18. Divide both sides by 2, divide both sides by 2. You get x squared equals negative 9. So then x equals plus or minus the square root of negative 9, which is plus or minus 3i. Okay, so there are 4 answers here. I have 1, 2, 3, and 4. There are 2 of them there because there's one that has a plus and the other one has a minus. Okay, so I only gave you kind of part of the graph. This graph actually does come back up and go like this at one point. We know that because it's a quartic and it has end behavior up on this side, so it's got to be up over here. But let's just work with what we know from the graph right here. It looks like x equals 0 is a solution, x equals positive 1 is a solution. Go from there, solve this equation using synthetic division, and then come back and watch me finish it. Okay, so here's the thing. This x equals 0 doesn't actually tell me much because I could see that there's a common x in each of the terms. And so I should be able to factor out an x from everything first. So x times 4x cubed plus 19x squared minus 8x minus 15 equals 0. Now I'm going to take the solution x equals 1 and divide this resulting polynomial by this. So what do I get? Let's see. I'm going to divide by x equals 1. So my solution goes in the corner of the box when I do synthetic. I write the coefficients out. 4, 19, negative 8, negative 15. 4, multiply, I get 4. Add, I get 23. Multiply, I get 23. Add, I get 15. Multiply, I get 15. Add, I get 0. This makes me very happy, so I draw a little smiley there. Okay, so then, what do I have? I have my x from the original thing. Then I'm going to use this x equals 0, or sorry, this x equals 1 to rewrite it as a factor, so x minus 1 is the factor. So x minus 1, remember that's what we divided by right here, that's why I have that 1 there. And then what do I have left? I have 4x squared plus 23x plus 15 equals 0. Now, we got to use the zero product property and strategies for quadratics. So, hey look, I think this factors. AC is 60, B is 23. Two numbers that multiply to 60 and add to 23 are 20 and 3. So 4x squared goes here, 15 goes here. I'm going to use 20x and 3x. So this is not new. So I'm going to have a 5 here, I'm going to have a 3 here, I'm going to have an x here and a 4x. And this all works, so my new factoring is x plus 5 times 4x plus 3. Okay, equals 0. Again, we apply the zero product property, so we say x plus 5 equals 0, so x equals negative 5. There's one solution, and then 4x plus 3 equals 0, so then there's my last solution. So I have 4 solutions here, 1, 2, 3, and 4. That makes sense because I have a quartic polynomial that I'm starting with. Okay, these two, I have a couple of patterns for you to check out. This is the sum of cubes formula, and this is the difference of cubes formula. Anytime you have an expression that looks like this or like this, you can rewrite them like this. It's just, it can be proven. It's something that I'm not going to prove right now, but it works always. Just pay attention to whether there's a plus or a minus, and then use the correct equation. Okay, so what I'm going to do here is I'm going to identify this as a cubed. But you can't just say that this is 64 cubed or 64x cubed. You have to think about what times itself 3 times gives you 64x cubed. And so what we have to say is a is 4x. And if you check your work on that, you can say 4x cubed, I should write that somewhere else, 4x cubed, the whole thing cubed, gives you, okay, well, it's 4 cubed times x cubed, which is 64 times x cubed, which is what we started with. And so that's how I can kind of show that that's what a is. I can do basically the same thing here, except 1 is a lot easier because b cubed is 1, and so b has to be 1. Okay, so I'm just going to erase a little bit here because... Okay, so now I know what my a and b are. I can kind of say, okay, I have a difference of cubes, so I'm going to use the formula at the very top of the screen now. I'm going to use this formula. So a is 4x, b is 1. Wherever I see an a, I'm going to write 4x. Wherever I see a b, I'm going to write 1. Here goes. Be careful, I put this whole thing in parentheses because that's what you got to do. It's this whole a squared, and the whole a is 4x. It's not just 4x squared, it's not just 4x squared, it's 4x squared. Okay, where all of the b's are, I'm going to put 1. Okay, 1 squared is still 1. 4x times 1 is still 1. 4x minus 1. Okay, so I can rewrite this as 4x minus 1 times, okay, this one is going to be 16x squared. It's 16x squared because 4 squared is still 16. And then I get 4x, and then I get 1 here. Okay, so then I could apply the zero product property and solve that way. I'm not going to do that here. You'll see me on the key doing this in the practice. Yeah, it's just a little thing. On the top one, or on the next one, I have a sum of cubes, so I'm going to use the next formula, the other formula. So x is a is x, and b is 5, because 5 cubed is 125. So I get x plus 5 times x squared minus 5x plus 25. And so that is equal to 0. Again, I could apply the zero product property, use quadratic strategies to solve that equation. I'm not going to do that here. This is just a little run through of a couple of formulas that might speed things along for you. This is not something you absolutely have to know. Okay, one other thing I just wanted to bring up is something that I had said already. I have common terms in these, and so I can pull an x out. And what I'm left with is x squared minus 8x minus 5. The reason I know that is because if I distribute these back through here, I will get back to what I had here. This is equal to 0. Again, you can apply quadratic strategies again here. Okay, the next thing that you might see is something that is factorable, but it says an x to the 4th and an x squared. So the first thing that I notice here is that I have a common term. I have a 2 in all of these because they're all even, so I can factor it out. And then I can divide by it on both sides. And I get x to the 4th plus 18x plus 32 equals 0. Now, x squared, sorry. Okay, now I can factor this thing. What is a? A is 1. B is 18. C is, I know I underlined the wrong things at the wrong time, I'm sorry about that, is 32. So AC is 32. B is 18. So we can use 16 and 2, just like we have seen before, but this time it's a little bit different. In the box method, I'm going to put my x to the 4th here because that's my biggest term. I'm going to put my 32 here. I'm going to take these 16 and 2, and it's got to add up to this 18x squared, so I've got to have a 16x squared here and a 2x squared here. What do I get? Well, on the outside, I've got to have a 16 here, a 2 here, an x squared, and an x squared. Okay, so then we could go, well, I can rewrite this as x squared plus 16 times x squared plus 2 equals 0. Then I can use the zero product property and solve. So x squared plus 16 equals 0, x squared plus 2 equals 0. Now you're thinking like, wait, I'm going to get all these complex numbers. That's okay. There's some i's there. There's 2 answers there. And then let's do the same thing over here. Minus 2, x squared equals negative 2. X equals plus or minus I times the square root of 2. There's the other 2 answers. Okay, so I know this is a little bit of a stretch from where we were at with factoring, but just know, hey, this is really the same process to get from here to the answers as if we were using factoring from quadratics. So it's super similar. It's just that you might see this form. If you see this form, then that means you should look to see if it's factorable. So if it doesn't have a cubic or a linear term, then you can maybe factor it. You'll have to see. One more thing that I'm going to talk about, I'm not going to actually spend time on this, but you can read about this. You can look at page 314 in the textbook to see this. It's an interesting theorem, and it's very true. It's really helpful for some things, but we don't have time to talk about it this year. It's called the conjugate root theorem. Check it out if you have time. Okay, I'm going to ask that you take the rest of the lesson today to practice. I put a worksheet out. I'm asking that you this time kind of label your steps so that you make sure that you're like showing your work and making sure that you're understanding about how you're doing the problems so that you have something to refer back to in the future. I'm going to show you kind of what I'm talking about when I say that. So I'm going to write my steps over here, and I'm going to write my answer work, my work over here. So my first step is look at the graph. And so I just typed in that polynomial, just this part, into Desmos, and I'm looking at where it crosses the x-axis. This is step 1, by the way. And so what I can say is we can write factors from the graph. And so step 2 is, okay, well, my two factors are x plus 1.5 and x minus 1. And I got those from these 2 points where they cross the x-axis. So let's start with this first one. So I'm going to divide 2 different ways this time. I'm going to divide by box method the first time. Inside the box, I want to get all of this stuff. And so I'm going to have an 8x to the 4th here. So then I'll have 12x cubed. So then I need to take away 16x cubed. Just kidding, I lied. I need to take away 18. Nope, 20. Okay, so then I have negative 20x cubed. Just kidding, squareds. I don't want any x squared, so we'll get there, but minus, so then I would have negative 30x squareds here, so then I have to add 30x squareds there, so then I have to have a 30x here, and then that would be 45 x's, but I don't want 45 x's, I want 27 x's, so I have to take away 18. So then I have to have a negative 18 here, so then I would have negative 27 here. And since this box matches this number right here at the end, that means that I'm done. So I guess this is step 3 here. I'm dividing by the first factor. Okay, so that's this one. So now I'm done with that. I can rewrite my polynomial. So step 4 would be rewrite as a product. So then I would rewrite this as x plus 1.5 times 8x cubed minus 20x squared plus 30x minus 18. Now I'm going to divide resulting polynomial by x minus 1, the other factor. Okay, so I'm going to do this in synthetic division now. So this factor gives me the solution 1. So then I'm going to write 8, negative 20, 30, negative 18. So add, I get 8, multiply, I get 8. Add, I get negative 12, multiply, I get negative 12. Add, I get 18, multiply, I get 18. Add, I get 0. Okay, so then step 6 is rewrite. So I get my x plus 1.5. Then I get my x minus 1. from the very beginning, from up here. There it is. Then I have what I get at the end of the polynomial, or at the division. So I get 8x squared minus 12x plus 18. And then this is equal to 0. This is equal to 0 here too. So now I can do step 7, which is zero product property and quadratic strategies. Okay, so I suppose I haven't been labeling, so I should probably write those things. So this is step 4 right here. This is step 5 right here. This is step 6 right here. And now I'm at 7. So I can say that. I can say x minus 1 equals 0. And then I can say 8x squared minus 12x plus 18 is 0. Okay. I get x equals negative 1.5. That's one solution. X equals 1. That's the other solution. Then I notice these are all even, so I can divide everything in sight by 2 on both sides. So I get 4x squared minus 6x plus 9 equals 0. Let's see if this thing factors. A times C is 36. B is negative 6. There are no two numbers that multiply to 36 and add to negative 6, so let's use the quadratic formula just because in reality that's what we're going to be doing. So x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 9 all over 2a. Hey, there are two things that I have noticed that you make mistakes on a lot. It is right here and it is right here. Some people don't make that fraction bar long enough and it makes your answer wrong. The other thing that people do is they put this in their calculator without the parentheses. If you put this in your calculator without the parentheses, then you will get the wrong answer. Negative 6 squared is negative 6 times negative 6, which is positive 36. It's not negative. If you write that it's negative, it's wrong. Okay, so I don't mean to be rude about it. I just mean to say, like, hey, you got to be really careful. So x equals 6 plus or minus the square root of 36 minus 4. Let's figure out what all that stuff is. 4 times 4 is 16. 16 times 9 is 144. I just used my calculator and paused the video while I was recording that. So, okay, and then divide by 8. Okay, 36 minus 144 is negative 110. So I can write 6 plus or minus I times the square root of 110, all divided by 8. I'm fine with it if you just solve and circle those answers. So let's circle our 4 answers. We have 1, 2, 3, and 4. We have 4 there because one has a plus and one has a minus. Okay, so this is sort of what I'm looking for you to do on these problems. I really want to see that you know what you're doing at each step and you can describe it and explain it and all that stuff. You should feel like you're getting it if you know how to explain what you're doing every step. So that's kind of the measure that I need you to be using to figure out if you know what you're doing. At the end of this video, which is right now, you're going to go back to the lesson. You're going to click on the worksheet. I need you to finish that worksheet. I need you to write out your steps. I need you to be really careful about how you're doing each of these problems so that you know that you are prepared for next week when we take our assessment. Okay, have a great day.